Okay, everyone, welcome to the seventh video. I'm Liang, and in this video, I'm going to introduce you how to use the kinetic and the rate. And be careful, this section is very, very important as it's closely related to your coursework. So uh, uh, please watch it again and again if you feel confused. And so if you feel very hurried for now, I would suggest you jump to the place you need. But in the future, I still hope you can go back and go through the whole video. So first, let's talk about the basic concept. So what is the kinetic and the rate? I think you have learned it in your lecture that kinetic and the rates controls the kinetic reaction. But you may have a problem like what's the difference between kinetic reaction and the reaction we used in the freak? The key point is the time. So it feels like the reaction, I mean the data block reaction we used in the freak. So that reaction is like it finished immediately. So it doesn't consider the time, but in the kinetic reaction, we should consider the time. So it feels like you take a train to the London and comparing with you take a portal to the London. So when you're taking a portal, you don't need to consider the time and the speed, but you need to consider that when you're taking the train. So as I mentioned for that example, you're taking the train, you need to consider the time and the velocity. So the velocity is reflecting to the rate in the freak, and the kinetic is like of the time you need to take. So now let's move to the uh, the definition of the kinetic and rate. So in the freak, the kinetic is used to define the time step, the initial conditions of the kinetic reaction. And for the rate, it only defines the reaction rate of this kinetic reaction. It sounds a little bit complex, but please go over again and again and totally understand what I'm saying. And afterwards, let's start our tutorial. So first, let's move to the kinetic. So as I mentioned, the kinetic is a function that can define the initial condition and also the time step of your kinetic reaction. So as you can see, we can see a quote here. So it means in this time, we are going to use the quartz to do the kinetic reaction. So here we can see the rate name is quartz, but we can also see some other things here. Excuse me. We can see some other things here. So these are defined rates. So that means in the database, this manuals has been defined already, and you can use them directly. Also, you can see the formula has also been defined already. But for some manuals, that is not included here. So you need to type something here. For example, blah, 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 something you want to make it a new manual. But in this case, we can just use the manual. It has been defined. It's okay. And even for your coursework, so we don't need to define it by yourself. And also you can define multiple minors if you want, and you can change the setting separately as you can change the window here. Is that clear? Like this? Yeah. So now let's move to the explain what's the details of each part. So first you can see the general parameters, which are the initial moles, the moles, and the tolerance. So first for the tolerance, I wouldn't suggest you to do any change here. You just use the default value, it's fine. But for the initial modes, the initial modes is like, if you still remember when we defining the equilibrium phase, we need to define how much modes we're going to add. So that it's same in the kinetic. So it doesn't mean all this like over 100 moles are going to melt it dissolved into the solution, but you need to prepare a lot as you're designed. I'm not sure what I if you're clear. It doesn't mean all of this will dissolve into the solution, and this value normally will represent will follows your literature review. So like you find some data and put them in. So another thing is that, so why did I set these two value as same? So this is because if you go back to the literature, the lecture slide, you will see here we can see the MK, the MOK, M0K. So it's like the moles of solute are given at a given time, and also the initial moles of solid. So that is like it considers you are at which step of the reactions because it controls the rates. And normally we do everything at the beginning, but sometimes if you do a kinetic reaction, for example, in the middle, somewhere of the reaction, so you can change the value of moles. So this is related to your reaction rate. And normally I would suggest you use the same value for the initial moles and moles. You don't need to consider too much. Okay. So, and also for the formula is already given. You don't need to make change. As you can see, it's given in the database. Only if you want to define some manual by yourself, you need to edit the formula here. Don't forget it. And finally, we can see there is like user parameters. What does it mean? So the user parameter, some people will feel confused, like where is the user parameter? What does it controls? So I will give you a simple instruction. So comparing with the given example, you can see here, the kinetic parameter is given here, like you have two parameters, and also in the rate, pay attention is very important here. So also in the rate, we can see it has AO goes to parameter 1, and V goes to parameter 2, and the AO and the V are used in the later calculation. Is that clear? So what does it mean? It means the parameter 1, the 23.13, reflecting to the parameter 1. And this 0.16 reflecting to the parameter 2. Is that clear? So think about it. Try to think about it. So the kinetic parameter is defined here and will be used later in the rate. That is very important. If you don't define it and you need two parameters in your rate, the calculation cannot start. It will fail. Uh, so always be careful with that. Always remember to define it. And also what the physical meaning of these two parameters is given by the formula. As you can see, it says the AO is the initial surface of quartz. So for this part, it's based on your literature review. You need to find out a number and put it there by yourself. Okay. So now let's move to the second page, which is the ODE method. So for this page, I wouldn't suggest you to go much further. Do not make much change. So it's like if you are familiar with mathematics, you will know it's the Runge-Kutta method, which is a way to do numerical simulation because you can see the reaction rate is actually a kind of ODE. So we use the ODE method to solve the mathematical problem. Mm, but in our coursework, we don't require you to go further in this part. So only if you have some like personal understanding, so want to do something further. Otherwise, I wouldn't suggest you do any change here. And finally, let's move to the final part, which is the time. So it looks very familiar with the reaction, but pay attention. This time we control the steps by time rather than moles. So it's not like how much things we add into the solution. So this time is like how much time we let it react in the solution. And normally the unit is set as 1 second, but you can type something here. As you can see, it typed like 5 year in 5. So it means it will translate into the seconds directly. So don't worry about that. Mm. Okay. Now let's talk about the rate. So the rate, as you know, is it controls the reaction rate of this kinetic reaction. But actually, in our study, we don't need to go much further in this point because the rate is totally different for different minerals. And as you can see, the formula is given here. Normally what you need to do is to put this formula into the reaction. But in this time, we don't need to do that because the rate has already been defined in in this database. But does it means we don't need to care about anything? That's not. So just let you know what you need to consider when you are doing your coursework. So for example, in this case, because we can see the quartz has been defined, but what if I want to use another miner? So for example, if we want to use the K effect, what will happen? So the key point is, uh, in in the quartz, we know the physical meaning of these two parameters, but in another miner, we don't know. So where can we find it? Because uh, as you may learn from the lecture, so for different miners, the rate is different. So where can we find it? We need to know what's the rate working in other miners. So then we need to go to the database. The database you can see here on the bottom, so the black one, which shows the database. So in the database, it's a lot of things you can see, but it's too complex. We don't need to go much further in this part. So we just directly go to the bottom of the database and go back. So if we go back, go back, go back, and we will see something very familiar. What is it? It's the rate. So here is the defined rate I mentioned. And the key point is, what are we going to do? What should we do? Is that find out the parameters we need to define. Is that clear? Find out the parameters we need to define. What parameters is here in the kinetics here, the user parameters. Is that clear? Okay, so here in the database, we can find just in the statement says, so the parameter 1, you can see the parameter 1, the spatial area, the parameter 2 is the adjust the lab rate to field rate. So these two parameter is what you are going to find out when you are doing your coursework, when you're doing your personal design. you're using a different manual, that's what you need to find out. So you can see that the definition is totally different with the quads, with the value you use in quads. So that's what you need to think about. For the rest of them, actually, I don't suggest you to do much change, especially don't do any change in your database. But just you need to know what you are going to find out. Because without these two parameters, the simulation will not start. You will always see warning, error, something like this. So hope that is clear for you. But if you are doing the tutorial for now, you don't need to think about this part. Just finish your quads. That's enough. Okay. So I think that's everything for today's tutorial. And once again, if you feel this anything you're not clear, you can always find me through this email address. You can send me a message through Teams by finding using this email address, and also you can send me emails. But we are not allowed to give you too much comments on your coursework design, but we can do some like technical support to your coursework. If you are not familiar with the software, if you don't know how to do something, how to realize something, you can always find me there. So, good luck to your coursework. See you next time.